We'll now do a quick overview of the relay monitor window. We do that by clicking on one of the nodes that we'd like to monitor in the network and open a monitor window with this button. And then we have the relay monitor window of node number 1 pop up, and that basically gives us a complete view of the front panel and the internal controls of that particular node. This is the speaker top node that we labeled with our friendly name speaker top to help us remember where it is. If we forget to register it, or if we deploy it without being registered in the database, we can actually register over the air here, which puts this GUID in the network management database along with whatever name you put here. You just hit enter and it gets registered. The radio temperature is listed here so you can keep track of the temperature at each node. If the polling is on, the poll list of whoever this guy is polling is shown here. And this section shows the transmit and receive channel select mode. This is by default in auto, which means all of the channel selection for both the transmitting and the receiving of this node is done automatically. However, we allow you to switch to manual and override the transmit channel. And if you rescan and change the receive channel, you will lose this guy from the window that you're being monitored. So you need to be careful that you note whatever receive channel this guy is set to if you're leaving him in manual. But typically that's to allow you to change the transmit channel. So we like to leave it in auto in case, unless there's a difficult interference situation within the venue. Again, the transmit side is the transmit channel. The transmit power, typically leave this at full power unless there's some issue with nodes being too close. The other thing we've added here recently is a transmit enable. Each node will receive a signal from an uplink node and retransmit that to anybody downstream. However, in venues where these nodes are closely packed, you may want to turn off the transmit signal of certain nodes just to not saturate the area with too many transmit signals. So this now is basically a receive-only node and does not retransmit the signal downstream. So again, this allows you to fine-tune a venue and choose which ones are relay versus receive-only. So we'll turn him back on. Again, ALO is the automatic link optimization for each link from one node to another. And this is the transmit ALO. So again, the way ALO works is any downstream node that starts getting an exceedingly high packet error rate and one that exceeds the threshold that you set down here can go offline, rescan the local RF spectrum, and tell the uplink node, which is this guy, to change channels. And if ALO is on, he will do so. If you turn ALO off, he will not. He will ignore the request to change channels. If you've got 2 or 3 nodes connected to this guy, you may want to do frequency and channel selection manually instead of automatically. So you have the ability to turn off ALO on the uplink side of a link and restrict that to not changing channels, even though the downstream node guy is experiencing a high packet error rate. In the audio section, we have again the LED bar graph. We have a gain control. You can increase or decrease the gain to keep from saturating the A to Ds and D to As inside of the unit. 0 is typically where you like to keep it. That'll give you a good high output level. And again, you can control the volume at each remote node from this particular case or location. So it's a big convenience. The other thing that we've added to the nodes is the ability to delay the output audio signal by up to 500 milliseconds. So this lets you essentially build a delay stack. And what we do is when the signal is received at this node, which is transmitted at the speed of light, we can delay putting it out on the audio output port by up to 500 milliseconds at that node. So you have a built-in delay control here. The other thing we do is we either relay the received radio signal immediately downstream, or we can have it as a cumulative delay so that the radio signal itself is delayed before it's retransmitted downstream. So that's the non-cumulative versus cumulative delay factor. Typically, you can leave it, in non-cumulative and add a delay at each node, especially if they're not exactly in line with each other and they're sort of in an L shape. You don't want to have a 500 millisecond delay between two nodes that are essentially in the same audio wavefront as each other. So it gives you that flexibility. Again, the audio output connector is selectable here. If you have typically an XLR balanced output, that's what you want to use here. Again, unbalanced, which means you've got signal only on, say, for example, pin 2. And then unbalanced stereo, we mentioned the input stereo on the master. This is the output version of that, where we take a single mono received signal and we split it into tip and ring of the output connector so that you can actually feed the same signal into two separate left and right channels of a stereo amplifier. Again, it's just a convenience to prevent you from having to cobble together external cables for the output of this thing. So those are your audio output connector selections. In the receive section of the relay monitor window, we have the receive channel, and again, this is typically left fully automatic, but if you, for example, redeploy a node that might be closer than the one that this guy is receiving, you can do what's called a manual rescan, and he will research, he'll go offline, do a scan, and reacquire the strongest signal. So again, if you put out another node that's actually closer and you want him to rescan for that, you can hit this, he'll go offline, scan for the strongest signal, and automatically pick that up. The uplink node ID is the node from which this guy receives his signal. So he's the downlink, and the guy upstream from him is the uplink node. Uplink node 0 is the master. So this is how you can tell who he's receiving his signal from. As well as the uplink control channel. This is the UCC channel, again, that the master is receiving. So he's transmitting the uplink control information on channel 10. The packet error rate is the number of drop packets in a few second period. It's an average over several seconds, and you want this to be 0, as close to 0 as possible, which means you want to make sure that your receive signal is high and there's not a lot of interference in this particular area. ALO, again, if this guy is receiving or having packet errors, and if the packet errors are more than 0.3% of the total packets sent, he will go offline, rescan, and send his scanned information, list of channels, desired channels, to the uplink. So if we want to change this to a lower, we can say 0.2, for example, and then his threshold, which is over here on the packet error rate, will come down to 0.2% packet errors before he does the retransmission request, or the channel change request is what it is. So we put him back at 0.3, which is the default. Again, this is a personal taste kind of thing. It depends on, the quality of audio you want at the event and how willing you are to have a few dropouts and tolerate the interference in the area. If you want to just go ahead and request a rescan, you can do that by pressing this button. So he's gone offline, he's rescanned, he sent that information to the uplink. If the uplink ALO is enabled, the uplink channel will change, or the transmitted channel from the uplink guy will change. If he doesn't change it, then he goes back and reacquired. You can see that's fairly quick. It's only a couple of seconds of signal loss and then reacquisition. And during that time, the audio will drop out. So you need to be careful. This is typically for the initial deployment and picking the right locations and antenna positions and things like that. So that's what ALO is, and that's the rescan request. Here we've got just an indication that the frame is locked, which it always will be. If you can see this window, it's locked, and which antenna is being used to receive. What we didn't mention is that we do have 2 antennas on the unit, both of which are constantly receiving, and the unit itself will pick the stronger of the 2 signals. So what you'll also see, and I'll move in front of the transmit antenna here, is it doesn't take much to really make that signal move around. And as you interfere with the path, the direct line of sight of the antenna, the signals will move quite dramatically in certain cases. And again, the unit will select the stronger of the two signals to receive. And that's the digital indication of the stronger of the two signals. On the top right, we have the RSSI monitor, the received signal strength indicator, which shows you the actual level in real time of the received signal at the node. So this is a very powerful thing. This gives you, again, the ability not to have to walk several hundred feet to go check on the received signal level. You can just do it from the central monitor and control point, and you can see the level of each of the two antennas in real time. And below that, we have the packet error rate indicator. Again, a relay unit knows when he should have received a packet just because of the timing of the packet transmissions from the uplink signal. And if he doesn't get one, he'll register a blip here, and he will mute the audio for that very short period of time. So at this point, we have no packet errors, and you're seeing the red line at 0%. So that's a good indicator too. Now, one other really important thing that we've added is called a remote spectrum analyzer, and that's just the other tab in this window. When you issue an RSA, or a remote spectrum analysis of that remote node, again, this is 300 feet away, he does a scan of the RF spectrum in his area, not the master. The master cannot see the interference levels 300 feet away or 600 feet away or 900 feet away. So each unit can be asked to go offline and scan for the signals in their area. And so you can see the interference at the node 1 location as this red, as these red bars here. And you can also see the signal strength of the master signal that he's receiving. So this is a very powerful way to keep track of, just how much interference is there, if it's changing, if there's something new, etc., etc. The other thing you can do is you can see on that same graph where my uplink control channel and my transmit signal are. These two bars here, their levels are just an indication of where they are. The actual levels are maxed out, so you can't really receive them, but this shows you which channels they've selected to operate on. And again, if you do manual channel changing here, those will change to a different place. So you can just toggle those on and off just to keep track of where they are. If you want another update, you just hit this button. Now this goes offline and scans pretty deeply for interference. So it takes about 6 seconds to do the scan, during which the audio output is muted. So when you're doing an RSA, you want to make sure you do this before the event goes on, or if you do it, you'll have to know that you're going to have 5 seconds worth of muted audio during that transition time. So that's the remote relay monitor window. It's, again, a very powerful window to give you complete control and monitoring capability for every node in the network.